All right, final review, Unit 7, numbers 1 and 2. Again, we're using the final review packet that you should have already picked up in class. Number 1, given ABC with angle A equaling 45, ABC, angle A equaling 45 degrees. Exactly. B is 30 degrees. Little b is 6. And find little a. And yes, it's not drawn to scale. All right. Law of sines is the one you try to use first, and then law of cosines if you cannot use law of sines. In order to use law of sines, you need to know an angle and its corresponding side. This is 30. And do I know its corresponding side? Yes. Then I can use law of sines because I know 45 and I'm looking for its corresponding side. So I would have sine of angle 30 over what's its corresponding side? Equals sine of 45 over what's its corresponding side? A. And then you cross multiply. Do you have to use the inverse key on this one? No, because we're not looking for an angle. Good. You only use the inverse key when you're looking for an angle. All right, questions on 1. I didn't plug it in. What was that? Yes. Okay, number 2. Again, triangle ABC. B equals 60 degrees. Little a is 14.4. And little c is 5. Find B. Now, what if a friend tells you, hey, Pythagorean's theorem, a squared plus b squared equals c squared? Yes or no? Why? It's not a right triangle. Good job. Does everyone see that we cannot use Pythagorean's theorem because it's not a right triangle? Yes? All right. Law of sines is something we'd like to use. Now, I know 60 and I'm looking for B. I know 14.4, but I don't know its corresponding angle. I know 5, but I don't know angle C. So can I use law of sines here? No. No. So we're using law of cosine. What side am I looking for again? B. Does anybody remember the formula? I'll start you off. B squared equals?
Oh, I have it. B squared equals a squared plus c squared minus 2ac times cosine of b.
Good job. Did you have that memorized or you looked in your notes?
I wrote it in my homework.
You wrote it?
On my homework.
But
I got it from my notes.
Okay, so she got it from her notes, found it, and I had kids like, oh, I remember that. And some kids, no, we never did it. Yes, we did. She just verified it. It's in the notes. So look back in your notebooks. It's there. B is what we're looking for. A is 14.4 squared plus c squared, so it's plus 5 squared, minus 2ac times cosine of angle B. And after you plug it all in, what do you do to both sides? Square root. Remember, square root answer. Or can you hit the square root key first and then plug all this in your calculator? If you want to. It's up to you. All right, so do that. You can check the answers in the back. Are we good with Unit 7?
Hold on. Can I look at this for a second?
Mm-hmm.
This unit I did good on, I'm not good at it.
Okay, we're good? So again, you plug it, if you hit the square root last, you'd plug it all in, and then you'd hit the second squared key, and then second answer. Okay, are any others from 7 clarifying anything, or are we ready to move on to 8? Ready? All right, Unit 8. We are going to make a few changes on Unit 8. Are you ready? Are you okay if I write on your packet?
Yeah.
All right, number 1, we're going to change to point slope form. Did everybody hear that? Unit 8, number 1, we're changing to which form? Point slope form. And we're also going to cross out 11 and 12. We've made changes to our units with you guys this year because of what you've learned last year in Math 3. We used to teach this, but you guys did a big unit on this in Math 3, yes?
Yeah.
Piecewise graphs, and so we took it out, figuring you guys have been taught it already, so it will not be on the final. It used to be on the final, but it is now taken out. So you can take it off the review. What was that?
So good.
All right, so everybody make those changes? Okay. Unit 8, questions, problems you want to see worked out.
Just the section 3 through 10 now. I just forgot how to do all that. I couldn't find it in the notes either.
Graphing.
I couldn't find that in the notes. I just was confused.
Yeah, and I didn't catch that earlier either. Those are not on the, those are other ones that we've cut out. You guys got it easy.
Like 3 through 10, heck, that'd be-
Yeah, 3 through 12 now. 3 through 10, 11 and 12. Again, those have been taken off the test as well. You did learn it before. Do you guys remember the shift right, left, half the sideways parabolas? You know it, but it's not on there because we didn't do it in this class. But I'm glad you looked for it and you said, yeah, I couldn't find it. All right.
Okay, do 16, 24, and 26.
Yes, 16, 24, and 26. With my morning class, we did a few of these even odds. Anybody need a refresher on even odds? Yes? Okay. Even is even when f of negative x equals the original function. It is odd when f of negative x equals the opposite of the original function. All right, so when we do from Unit 8, number 13, f of x equals x cubed plus 2x squared, what do I plug in for the x? I'm looking for f of negative x, so what do I plug in for the x's?
Negative.
A negative x. And I forgot my sign on that first one. What power is it? Third. Negative x times negative x times negative x is negative x cubed. Plus 2x squared or minus 2x squared?
Minus. No, plus. Still.
Plus, because a negative times a negative becomes positive. All right. Here's the f of negative x. Here's the original. Are they exactly the same? Yes or no? Not exactly the same. Opposites means if you were to distribute a negative here, you'd end up with this. If I were to distribute a negative to both of these, it would be negative x cubed minus 2x squared. Is that the same as this? Yes or no?
No.
Is it the opposite? No, so it means it is neither. It's not exactly the same. They're not opposites. Therefore, it is neither. Questions? X squared plus 7x. Here is the original. And then we go through and we find f of negative x. What do I plug in? What do I plug in?
Negative x.
Negative x. What's negative x times negative x? Positive x squared. Plus 7x or minus 7x?
Minus.
It's either exactly the same or exactly opposite. This is positive, 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 negative. Are they exactly the same?
No, not exactly.
They're not. Opposites means you take the opposite of everything. If I take the opposite of everything, would it be this?
No.
No. So what would we say?
I say neither.
It would be a neither. All right. The only part you want to be careful on is if it's a fraction, it's not opposite of the numerator and the denominator. It's the opposite of either or, and it doesn't matter which one. Can anybody tell me why a fraction you wouldn't do opposite of the top and the bottom?
Because if it's like a negative and negative, then it becomes positive.
A negative and a negative become a positive, and is the positive taking the opposite? No. So you take the opposite of one of them. Would you like me to show you the fraction one? Okay, that is number 18. F of x equals x squared minus 3 over x. So we're going to compare to this one at the end. And we do f of negative x blank squared minus 3 over blank. And what do I plug in the blanks? What's negative x times negative x? Positive x squared, f of negative x. Positive x squared over, minus 3 over, all right, so this is what I'm comparing it to. Did the top stay exactly the same, x squared minus 3?
Yes.
Did the bottom stay exactly the same? Did it become the opposite? So is it okay to take the opposite of only top or bottom? Does it matter which one? No, so would we say even, odd, or neither? It's odd because it's the opposite. Why is it the opposite? Because x became negative x and the top stayed the same. Got it? Which one did you want from that section? Did I do it?
None from that section.
Okay.
Oh, 16.
Okay.
That's just now that you're dealing,
It's
I did
even.
them wrong in general.
Okay, yeah, so 16, why would 16 be even? Can you guys look at your paper?
Because there's no x and it's the same.
There's no x, which means it would stay the same. You're right. All right. Questions on this piece before I move on to the rest of Unit 8?
Would 17 be the only odd one?
Oh, and
This one is, 18's odd.
22.
You want to see 22? All right. So you can be writing these down even though you don't have your packet. Okay, so I'm still on Unit 8, and you said which one, 22?
Mm-hmm.
Any others besides 22? On my laptop. Thank you.
26.
26, is she the only one who did her homework?
Yes.
The rest of you guys should be writing it down now.
The phone.
Right under my laptop, there's a little drawer. It's kind of hiding. The rest of you guys, if you did not do it, you're doing it now. Put your phones away. What was that?
B21.
21. All right, starting off with 21. Is that a domain question?
Yeah.
This is a good one to go over because you do need to know the domain questions for the test. There's 2 restrictions on this one. What's the restriction for a fraction? The denominator cannot equal 0. Do you agree? What's the restriction for a square root? For a square root, not a cube root. The inside must be what?
Greater than 0.
Greater than or equal to 0. But you gave it to me the right way. If it was just like this, we would say greater than or equal to 0 because you can take the square root of 0. Do you all agree? Why on this one combined would it be 5 minus x is just greater than, not greater than equal to?
Yeah.
Why?
It's in the denominator.
Because it's in the denominator. There's 2 restrictions. Yes, the inside has to be greater than or equal to 0, but because it's in the denominator, it cannot equal 0, so it's just greater than. You do need to know that for the test. How do I solve this?
Set it. Solve it.
Minus 5. And that gives me negative x is greater than what? Negative 5. Divide both sides by
1.
X is
Less than 5.
less than 5. I'm positive because you divide the 2 negatives. All right. You will need to know how to write this in interval notation. I'm not sure if it asked you on this one, did it?
Yeah.
You do need to know that for the test. You don't have to graph it, but for those of you that just have forgotten how to write an interval notation, is it open or closed?
Open.
Shaded to the right or to the left? If it's x is less than. And how do I write that in interval notation? Negative,
Infinity to 5.
comma 5. I always use parentheses on an infinity or negative infinity. What do I put on the 5 since it's open? Do you think they would have this as a distractor?
Yes.
Yes, you're like, oh, greater than or equal to, because that's what Mrs. Torres said about square roots. Yes, as long as the square root's not in the denominator. Do not be tricked by that problem. All right.
So the numerator has no bearing on the range then?
On the domain for
Or the
fractions,
domain, yeah.
no. Unless the fraction had a square root, which it's not going to.
Okay.
All right. 22 is a good one. I'm going to pause right here and tell you guys that you need to know this for the test. So if you haven't been paying attention, shame on you, but focus in now because you do need it. All right. 8 f of x equals 8 all over square root of x squared minus 5x plus 4. Originally, is it like number 21 as far as the restriction goes? Okay, so we know square roots have to be greater than or equal to 0, but since this is in the denominator, what does it become?
Just equal to.
Just
Or just less than, greater than.
just greater than 0. Why no equal bar? Who can tell us?
It's in the denominator.
Because it's in the denominator. Do you guys see that? All right, this right here is the part that you have to remember. I'm going to start it off and you guys tell me when I start to mess it up. Okay. Obviously, it looks like I should factor, so I'm going to double bubble. X into X. I messed up. Negative 4, negative 1. And then I'm going to do x minus 4 is greater than 0, x minus 1 is greater than 0 because it makes sense to do that.
I'm assuming you already messed up.
I'm-
That's
and I-
exactly what I've done. So.
Okay. And I've messed up right here. And I do this because this feels most natural. And you said you did it, not because you didn't know how to do it, but it feels natural. Do you guys agree? No one stopped me. It's like, hey, why not? We only do that if this was a what? Equal sign. If that was an equal sign, I do x minus 4 equals 0, x minus 1 equals 0, and all would be good in the world. But once you throw an inequality in there, it changes things up. Does anybody remember what kind of problem it is?
No.
There were two things that happened together that made it this special problem. You're on the right track. When I had a problem that I could factor or that had a degree of 2 or higher and an inequality at the same time, test values. Need to know for the test. All right, did everybody hear that? Okay, how do you know when to do a test value? When you factor and it has a what?
Inequalities.
Okay, so this one up here had an inequality. Why was this one not a test value? Because there's only one solution, right? There's not more than one solution. Do you see that? When you have more than one solution, whether you're factoring or not, it's going to be a test value problem. Got it? Yes? All right, so step 1 is you actually find the zeros. And find the zeros means you actually set it equal to 0. So that's where you would set and find your two solutions. What are they? 4 and 1, and then you graph them. 1 and 4, open or closed if it's just greater than? Open. Greater than 0 means we're looking for positive solutions or negative solutions? Positive. Okay, we need 3 values, to the left, middle, and right. I like to use 0 whenever I can. When can I use the 0? Left, middle, or right? Left. Give me a number between 1 and 4. 3, and a number bigger than 4. 6 or 5. All right, so we plug it in here into the factored form, and we're trying to see whether it's positive or negative. Do I care what the value is? Nope, just positive or negative. So right here, what's 0 minus 4, a positive or a negative? 0 minus 1, a positive or a negative? Which equals a positive. 3 minus 4, positive or negative? 3 minus 1. And when you multiply that, you get a negative, and then you 6 minus 4, and 6 minus 1. Would I still get positive if I had used 5 that somebody said earlier?
Yeah.
All right, where do I shade, outside or inside, if it's greater than 0?
You shade on the outside.
Because those are the positives, right? So what would I have? Negative infinity, comma, 1, parenthesis or bracket on the 1. And then what's this? Union. And then 4 to infinity. Where are you going to see this? On the final. I put test here, but technically what should that word be?
Test value.
Final. It is test values, and it's on the final. Got it?
So
Why is it open circle on one?
Say it louder.
Why is it an open circle instead of a closed circle?
Can Alex answered that earlier, so can anyone other than Alex answer it? His question was, why is it an open circle and not a closed with the square root?
You know, because of the,
But why? Why is there no equal bar here? Where typically with square roots there is. Did no one hear Alex's answer? She answered like,
the denominator.
because it's in the denominator. Okay, did you guys hear that? Because no one was able to answer it. So why? Okay, because it's in the denominator. Okay, questions? All right, we've run out of time, so I'll have to continue this tomorrow. Do you guys want to see 27 or 28 tomorrow?
No.
No, you guys are okay with that? Yes, yes, we're okay, or yes, you want to see it?
Let's do one of them.
Okay, well, we won't have time right now.
No,
'cause
no,
it-
no, no, tomorrow.
But tomorrow, yes. All right, we're good? What assignments